Hello everyone, we are from the C23 PC644 team. On this occasion, our team will present the results of the application that we made to fulfill the capstone project task. This is our team, and as you can see, this is one of the facts we found in the kupastuntas.co, that the article regarding complaints patient in very long treatment queues cause harm to the patient's family. Apart from that, in the Trust Medis article, we quote a sentence stating that Permenkes 2008 about the standard for patient satisfaction with health services must be above 90%. One of the indicators is the long waiting time. Have you ever been in this situation before? To stand in long queues to get treatment at the hospital? How do you feel? Are you emotional? Are you frustrated? Or you will even immediately switch to another health service? Compare with this picture. It looks comfortable, right? With a few people waiting in line, you can make your times more efficient if you have this information service. Have you ever asked, how about the quality? And how about the facilities and availability of health professional? Would be great if you get the queue crowd information, get information on facilities and health professional, get information on the nearest hospital. Let me produce you our application, proudly present medical overseas control. What is MOC? MOC is an application that can help inform hospitals and patients about the direct hospital quotas. MOC can help users and patients check in the real-time hospital's queue information and quotas so they can arrive at the hospital on time and time is not wasted. By using our service, user can get information about hospitals information and estimate quota based on queue information. Users can see whether the hospital is busy or not based on the application we made. There is a similar apps with our app. There is Okadoc. Actually, someone has made an application similar to our application, but still the application has differences from the application that we make. And how can it be different? The main differences is the queue feature. We want our application to be able to help patients in increasing time efficiency as the main goal, reducing waiting time and minimizing crowding in hospital waiting rooms with real-time information.
Then, how our mock app works. After you log in, our app will give you a list of hospitals near you, or you can just search it. Or you can just find where you want to go. Our app will provide the prediction about the situation and others important information. If you frequently visit that place, bookmark it. Are you curious how our application runs? And this is the application architecture that we create for the application. It always starts with the Android mobile app. And then all the data that display on the Android application is obtained from remote communication with Google Cloud via the REST API utilizing the retrofit library on Android. Within the Google Cloud, we use Cloud SQL to build the infrastructure of our application database. And for the API model, we do a separate deployment with Fast API to connect with Google Cloud. Specific for the app, our app using MVVM architecture, which complies with the instruction in the Android documentation.
Okay, next, we'll take a look at our cloud infrastructure. At the first layer, there's our client, the mobile app, and the hospital client app. These clients are connected with the Google Cloud application layer. The client can only talk to our main API, which is our Express.js API that's powered by the App Engine platform. Our main API then forwards the client's request to either the Cloud SQL main database or our AI model that is using Fast API. For example, this request can be mobile app users doing a CRUD operation on the MySQL database, or a hospital client extracting estimated people in an image with our AI model API. After your request is processed, the main API then send the process data back to your client app.
This is our machine learning architecture program. The input image will be resized and processed into matrix two-dimensional with a convolutional layer and retest its burdens with pooling layers. After that, the matrix will be flattened into one-dimensional matrix and process it into dense layers. After that, we do some regression to generate a bounding box for detection object. Next. This is our loss function from training model. Next. This is our training visualization in TensorBoard. Next. And this is our evaluation visualization in TensorBoard. Next. From the image above, we can see that the performance can be varied, depends on background, contrast, and overlapping object.
After all that implementation architecture that we made, this is the result of our project for medical oversee control app. If you're curious, want to watch the app demo, you can visit the link below. We also make the documentation for our project capstone in GitHub organization. You can also check in that link.
For our app, we use local deployment with a local infrastructure, such as local software or a local network, instead of using a remote or a code-based infrastructure. Use it because it gives several advantages like performance and data security. We need 5 months for local deployment, where each month we will divide the roles and responsibility to be done. For August, the engineer will build the MVP. Then in September, engineer will add new feature for the app. Then after the app finish, the marketing will launch and branding the app. After that, in November, analyzing the app and see what need to be added to increase consumer satisfaction. Finally, in December, the engineer will evaluate and updating the app. Next.
In the market plan, we can see in the value proposition, we offer the value of efficiency for the user regarding the personal experience of Indonesian people who have a problem with QE in waiting room. Next. In the SWOT, we examine the pros and cons of our product. In the strength, we have advanced object detection and visual appealing design, and the threats are coming from the number of competitors in the business. Our target market is the patient with all range of age, profession, and roles. So why target market needs our solution? The value that we offer of time efficiency is important, especially for Indonesian people who didn't like waiting.
If we have 5K funding, this is your budgeting, but a majority is operational costs, followed by application formatting and marketing. Next. Then if we have 10K funding, the operational cost is still the highest, followed by additional pay and wait for new personnel. Next.
The project milestone is start in August. First is to make MVP and edit feature, then launch the app, research the feedback from the user after use the apps, and the final is evaluate the apps based on the feedback.
Thank you for listening to our demonstration of application.